So today I'm working on trying to figure out whether a certain approach to production is going to work for our SpiceVice. Let me take a step back and kind of explain how we got to where we're at. Initially, this was going to be the shelf for the SpiceVice. And there was something I thought very elegant about a groove running down the side of the part all the way down, and just one part fitting right in, and voila, you'd essentially have your product. It would be press fit, probably enhanced by some epoxy, but basically, the part would be press fit into the side. What ends up happening, though, is that the manufacturer that produces this part has a plus or minus 1 degree tolerance on the bend angle, which is to say, given that there's 6 bends, 1, 2, 3, 4, 5, 6, you could technically at the end of the process end up with this edge being off by 6 degrees if everything was off by a degree in the same direction. Now that doesn't usually happen. It's kind of usually off on one side a degree, and maybe off, maybe not, but maybe on the other side. But the problem is, even if it's off by a little, this 1/8 thick material is so rigid, there's absolutely no way you could kind of bend it to kind of force it into the part. The CNC operator, this is going to be a very precise groove, very straight, very square, 90-degree angles. And if this part isn't as perfect as the groove is, you're just not going to be able to get it in. So then the thinking was, okay, well, let's go to a thinner gauge shelving material, which is what we have here. And as you can see here, this is flexible. And so the thought was, okay, we'll put thinner grooves and this thinner piece, and everything will be fine and dandy. The problem we arrive at is that the CNC fabricator who's making these wood parts, when you get to that thin of a groove, the drill bit that they're going to use to run that groove, it's just too small a diameter of a drill bit to get the groove as deep as we want it. We're going to experience a lot of breakage. They've got to slow the machine down. It ends up just being a difficult process that they don't want to do. So the sort of low end, the smallest width that they can accommodate and still give us a depth, and that's what we're going to check today, still give us a depth that hopefully will work, is 3/32. So this part here is 3/32. You can see it's noticeably thicker than that skinny one we had done before. So this 3/32 part, is a compromise. Now, the reason why we broke this kind of one shelf approach into parts is that at 3/32 thickness, this is still very rigid. So we really can't afford to have that the bend angle tolerances flow all the way through the part and end up with something that we can't bend and get into the grooves. So by limiting, 2 bends per part, essentially, you kind of take care of that. What the CNC fabricator has informed me is that they can do the 3/32 of an inch wide width of this groove. However, they can only do it about a 1/4 inch deep. And so that's what we're going to test today, is to see whether or not this thing being press fit into a 1/4 inch deep groove, which is just this, is going to provide the integrity that we need for this product. Now, just to give you a little information, these little notches here are designed to, first of all, when you press fit this into the part, it prevents from hydraulic press. If you press it in and the edges are super sealed, you're actually going to bump in against the air, and so it'll be harder and harder to push the part in. And also, to the extent that we use a little bit of epoxy in there to seal it in, the epoxy will flow into the groove, and then essentially when it hardens, create kind of a key. So preventing, preventing the part from sliding outwards. This little hole here is so that these parts can be hung by a little wire when they're powder coated, which is the finish that we have been working with over here. So you need this little hole, and the nice thing about this is, of course, once it's inside, press fit into the part, you don't see the hole anymore. So that is going to be what we're going to try today. Is we're going to mill into a piece of sacrificial. See, we did this here on this wood to see whether or not the 3/8 inch part would fit well. And this isn't flat, so I can't show you that. But we were going in a full 5/16 of an inch deep. Now we're going to try 1/4 of an inch to see whether or not that provides the structural stability we need, again, to ensure the integrity of the product. So that's the plan for today.